Hello everyone. In this video, we will be solving the question diameter of generic tree. So a diameter generic tree basically means the maximum number of edges between any two nodes in the tree. So the number of nodes between any node, number of edges between any nodes basically means, for example, between E and C we have 1, 2, and 3 edges. So diameter is the maximum number of edges between any two nodes in this tree. So there could be any nodes. For example, for this particular tree, the diameter would be 1, 2, 3, 4, 5, and 6. The diameter would be 6 for this tree, as there are 6 edges between any two nodes, which are E and M in this case. And so that's how you calculate the diameter. That's how you calculate the diameter manually speaking. But if you had to do it algorithmically, the strategy that you would follow is that first you would take a note, say this one, you would consider its children, and you would calculate the two highest heights. That is, you will calculate the height for this child, for this child, and for this child, and you will take the top two heights which in this case would be, it could be this one. I'll mark it with a different color. This one and this one. These two nodes say will give you the highest height. Of course, D can also give the highest height in place of B, but for example, let's just consider B as our correct answer. So one of the heights, the highest height is 1, 2, 3 for the child named C. For the other child B, the height is 1. To that, to this number, we will add 2 to accommodate for this edge and this edge. These are the heights to calculate the diameter, that is to connect this node and this node. To calculate the diameter, we have to use these two edges as connections. So we'll accommodate for these two connections edges by adding 2 here. That would make the height as diameter as 6, which we had just calculated a few moments ago. That's basically how you calculate diameter of a generic tree. Now, more often than not, there is a lot of confusion among students who say that, you know what, maybe, just maybe, every time the highest diameter that we're supposed to get will pass through the root. To that I say that sure, it can, but that is not necessary. It's not necessary. I'll take an example. For example, I have more edges here, say O, and then we have an edge here, say P, we have Q, we have R, S, T, U, and V. I think this should be enough to prove our case. This is R. Okay. So in this case, what will happen is that we'll go to the child, we'll go to each child and calculate the highest height that its children have. The height for this would be 0, 0, and then 1, 1, 1, 1. Sorry, not 1. 2. Height for here would be 3. Let's just follow the proper order. Then height would be returned here as 4. Then we'll move, if we're traversing with B as our node, we'll go to the second child. We'll get height 2, then 3, then 4. Then B's height would be the maximum of whatever the two values are, whatever all of its children's values are, plus 1, that is 5. The height seems to be 5 for B. Then for the other nodes, we have, let's just write the height directly. The height is 0. Then the height is 0, 1, 2. Height is 0 and 1. The value here would be 3. Now, we have the next child. We have height as 0, then 1. Then the height that is found at this node right here is 5 plus 3. The 5 is the highest, so the maximum height found here is 6. Now, what you were supposed to do was to calculate the highest height. And for our highest height, what we're going to do is take out the two highest heights, that is h1, say the highest height, and h2 as our second highest height in all of the children, that is B, C, and D. We have highest height as 5 and second highest height as 3. And for that, what we're going to do is take out the maximum height. We get our answer as 5 plus 3 plus 2 is equal to 10. Now that is the value of diameter that we find at root. But is that the correct answer? That is the question to ask. And the answer would be not necessarily. Let's check this particular node right here. The height seems to be 4. Second highest height seems to be also 4. And the diameter that we get here is 4 plus 4 plus 2, which is 10 again. Not really the highest. But what if we add another node here, say Z? Then this entire line would change. This height would be 0, 1. Basically, the height that we would have is 1, 2, 3, 4, 5, 6. The height found here would be 5. Then in that case, the highest height would be 5. Second highest height would be 4. Then the diameter found would be 5 plus 4 plus 2 is equal to 11, which is higher than 10. So 11 is our diameter, which does not pass from the root. The root taken, that is ROUTE, not the ROOT root that I was just referring to. The root taken would be going through here. This gives us the highest diameter, maximum diameter of this generic tree. That's the approach we'll be following. Basically take out the maximum height and the second maximum height for all the nodes, and then calculate the diameter by adding these heights plus 2 to accommodate for the links. And let's try to code this approach now. Firstly, we need a function. Before that, let's go to full screen. Yeah, we need a function, public static. So in this function, actually what we're going to do is calculate the height. We won't be calculating the diameter directly through this function. What we're going to do, we're going to take this recursive function, we're going to take out the height of every child, we're going to return this value in this same function, and we'll update the diameter accordingly. So basically we'll calculate something else, that is the height. We're returning something else, which is the height of that particular node, the subtree that its node has, and we'll actually be calculating the diameter separately. The way we're going to do that is we're going to take this function, call it height cal, naming it so that you don't get confused. We pass the root here, and we define our two highest heights for this particular node's subtrees. And I say, why don't the minimum height has to be 0, so we're just initializing it at a value that is lower than 0 so that we can update it properly. Now we're going to go through all the children of this particular node. Let's call it node, not root. And with this, what we're going to do is we're going to calculate the height of the particular child we're at the moment. Calling the same function again, but with child as the current node in this one. And now we assume that this will return us the height of that child's subtree property. And once we have that, we check if this height is greater than the highest height. The second highest height becomes the highest height that we had so far, and the height that was maximum at the moment will be updated to an even higher value that we have just encountered. Otherwise, we check if the height that we have encountered at the moment, is it actually greater than the second highest height? It maybe it's not the maximum height, but it can be the second maximum height, right? So in that case, we just update the second maximum height. And now that we have that, we can have a candidate. We have this node, we check all of its children, we get the highest diameter for this particular node, and we say that, you know what, you're a potential candidate for the maximum diameter of this generic tree. And so I say that you're a candidate and your value is the maximum height plus the second maximum height plus 2, which is the two connections that we use to convert these two subtrees into a diameter. So now I check if this candidate is greater than the maximum diameter. We still need to define this variable, but we will in a moment. If this is the case, then maximum diameter becomes this new candidate that we have. And now to return our maximum height for our current node, since we are returning height in this function, what we'll do is that we'll take the maximum value of we already have our maximum height in h1, so we have the height plus 1, because we had the highest height of our children that we had. So whichever is the highest height, we add 1 to it for our own node to add on to our height, and then we return that value to wherever we are being called from. And now we need to define a variable, static integer max diameter is equal to integer dot min value, that is the minimum arbitrary value. And now we call this function, and our function's name is heightcal. So we pass the root to it, and finally we print, you guessed it, the maximum diameter. And now we see if this approach works perfectly or not. Okay, our default case is passing, so let's submit it to see if all of our test cases are passing or not. And they are. So that's basically how you calculate the diameter of a generic tree. If you like this content, if you found this useful, feel free to drop a like, drop a comment, and subscribe to our channel. Thank you so much for watching.